Hello, welcome to the second stream, part 2. Right, I hope you guys can hear me and see me clearly. So, this is kind of, if you guys are coming from part 1, you just skip a few seconds because part 1 kind of ended abruptly. We were supposed to complete all 15 problems, but we there was some internet issue on my side and the stream got ended all of a sudden. So we'll just complete the last 3 problems. So I was solving part 13 when the internet got stuck. So we'll start with part 13 and then we'll do 14, 15 and then end it there. Okay, so problem 13, 14, 15. Okay, so let's get into it right away. Uh, so 13. So 13, I almost completed it. I didn't even know that the stream got cut off in between. And I ran the test cases also. It ran, I guess. So let me go through 13 again. So 13th program was progress update simulation, where you input how many tasks should run, and the output will be the progress percentage. So today, hello, hi. So I just saw your chat. Okay, so today we will see how this is done first. And if we see the test case, we'll start with the test case. This is kind of test driven development. I have my MacBook also here. So what we will do is we will understand what the test case is first and then we will work on it. Okay. So progress update simulation. Uh, Sorry. So let me just see. We will make it, let's say 10 tasks. Okay. So this input that we are giving here is 10. So for testing, I made it 100. So let's start with 10 tasks. So what the problem is supposed to do is, let's say you have a progress bar. Okay. And the total is 100. It starts at 0 and here is 100. Okay. Now you are supposed to run a multi-threaded program which actually ends up filling this progress bar. Okay, so how we are supposed to fill it? So let's say there are 10 tasks allocated. Now if the progress bar needs to be filled, you multiply 100 by 10. Okay, so each task will be doing 10 percentage. So you fill 10 percentage and then the next thread fills 10 percentage and the next thread fills 10 percentage. So in the end it will become 100 percentage, right? So that is what we have to make sure is happening. So this formula 100 by 10, which is equal to it is actually 100 divided by total number of tasks. Okay, so this is the formula we have to do in order to oh, there goes my screen. Did it get stuck? So this is also happening frequently. I don't know why. Let me fix that quickly. I think there is some issue with OBS, so I'll check that later anyway. Yeah, so this is what I was saying. There is 100 divided by total number of tasks, which will give me the final percentage to fill for each thread. Okay, so that is what I am doing in my threads as well. So if you see percentage completed for this thread is 100 divided by num tasks. So I'll do one thing. Since we kind of abruptly ended yesterday, I will remove all of this and start from the beginning. Okay, the 13th program. So we need an executor service. Executor service svc equals executors dot new single thread executor. Okay, and what I'll do is for int I equals 0, I less than num tasks and I plus plus, I will execute 10. So svc dot execute, and inside the execution I'll say I need to first of all calculate how much percentage of work each thread needs to do, right? So for that, what I'll do, we have the formula which we just computed here, which is 100 divided by total number of tasks. So the num task is the total number of tasks, right? So int percent complete for this task equals 100 divided by number of tasks. So you got the percentage that got completed for that task. You add that to the atomic integer which we have declared outside. So percentage complete for this task dot add. Oh, sorry, percent progress dot add, and we add this value. Okay, so which will add 10 for each thread. Now in the end of all of this execution, we check if the percentage is 100. Okay, now what we have to do, we have to also do service dot shutdown. Okay, that is done. And another thing we have to do is we have to wait for the threads to complete. So service dot await termination, and I will wait for like 1000 or 10 seconds. Okay, so I'll wait for a maximum of 10 seconds for all the threads to complete. Okay, so I don't think it will take that much time, but still I added 10 seconds is the maximum. Okay, so surround it with try catch to handle the exception it is throwing, and I will remove the exceptions. Okay, is there anything missing? I don't think so. So let's run the test case. Right click, run as JUnit test. Okay, so if you see which one were we working on, test progress update simulation, right? Where is that? Test, this one. So test progress update simulation passed. Okay, so with that, number 13 is done. Okay, 13 is done. Now let's move on to 14. So let's see 14. What does 14 say? Parallel computation. Okay, input is list of integers and output is sum of all integers. Okay, I hope my internet is fine. My preview is kind. Okay, if there's an internet calling part, you want to compute the sum of all the integers given in this list of integers, and so you have to have parallel callables which return kind of the partial sum and add it to a single entity. That is what they are saying. Sounds doable. Okay, so what we have to have, okay, let me try to write it down. So let's say, let me see what is the sample input. Parallel computation, right? This one. You have a list of integers 1, 2, 3, 4, 5, and the sum should be 15. That is what they're expecting. So let's see. One, two, three, four, five. Okay. And we are expecting 15. So we are supposed to call, like multiple threads, and then in each thread, you are supposed to add the result with the previous thread. Okay, so we will have, let's say I'm adding 3, 4, and one more thread for 5. Okay, I will have a counter like an atomic integer as a global variable which I'll initiate at 0. The first thread will execute and add 1 to it. The second thread will execute and add 2 to it. the third thread will execute and add 3 to it, and so on and so forth until all threads execute. So I think this is the logic that we are looking for. Did my screen get stuck again? Great. I really need to look into that. I think I have to run a system update or something. Fine. So where were we? So this is the idea. We just make sure that each thread sums to that atomic integer. So let's try that. I will start an atomic integer counter equals new atomic integer, and I'll start it at 0. Okay. Now for integer number in numbers, I need a thread pool also. So executor service equals new, sorry, executors dot new fixed thread pool. I'll start do just a fixed thread pool of 5 and let's see how that goes. Okay, I mean fixed thread pool of 1, there can be only one maximum thread running at any time, and for each number I will do svc dot execute, and in there I'll do counter dot add number. Okay, and then there will be svc dot shutdown and svc dot await termination for 10 seconds. Oh, sorry, time unit dot seconds. Okay, of course we have to wrap it in try catch and ignore the exception. Okay, so it's pretty straightforward. We are adding the numbers that are incoming, and we have to return counter dot get, okay, which will return the final sum value. Right, let's see. Let me rerun the tests. Okay, all tests completed. So this was test parallel computation example, this one. Okay, it passed. Okay, so this one passed. Let's do one more test. I will spawn 5 threads. So currently what is happening, thread 1 completes execution, then there is a thread pool, right? So let's say thread pool is like a bucket, and the bucket size is only 1. You can hold only 1 thread at any time. So what it is doing, it is taking the first thread into the bucket, it executes it and then throws it outside. Then second thread comes, executes and throws it outside. So let me try and create a bucket whose size is 5. Okay, so it can hold 5 threads at the same time. So what happens, all 5 of them get into the bucket at the same time. So okay, so 1 2 3 4 5 are all executing in parallel. Now is where we can actually simulate the concurrency of threads and see how good it is working. Fine, so I have this fixed thread pool of size 5. Let's run it and see. Okay, so parallel computation, where is it? Test parallel computation example, it still passed. Fine, so that is done, and with that we are done with 14. Okay, 14 is done, and we have the last problem. Let's go. So test shutdown and await termination. So this is the one. So shutdown and await termination. So gracefully shut down utility, and input is this, output is this. So it's simply they are giving us an executor service. We are supposed to shut it down and just return if it gracefully shut down. So let me see the test case. It's just taking a single thread executor and shutting down and waiting termination. So I'm not sure why. Is it asserting true? Yeah, it is asserting true as well. So this is kind of something we have already covered. So let's do it. Service dot shutdown. So first we have to invoke shutdown, then we have to service dot await termination, and it's the same thing. Wait for like 10 minutes dot time unit dot seconds. Okay, this actually gives a boolean of whether it passed or not. So if you see the Java doc of it, it says, okay, I just noticed that my screen got stuck again. I think there is Mac has a, what do you say, iteration that every 5 minutes it has to get stuck or something. Anyway, moving back. So service dot await termination. I'm waiting for 10 seconds. So if you see the await termination, it returns a boolean value, and the boolean is, where is it? True if the executor terminated and false if the timeout elapsed before termination. Okay, so this service is in effect doing nothing, so it should execute immediately is what I am assuming. So it wouldn't even take more than 1 millisecond. So this should immediately return it. So why we have to again return false is, let's say I comment this out, you see that it shows an error that this method must return a type of result boolean. So if at all some exception happened here, this method wouldn't return anything. So by default we'll make it return false, so that if at all an interrupted exception happened or something like that, we know that we are returning false. Okay, so let me rerun the tests. And it got stuck again. Okay, fine. Okay, and there we go. We finally see that all test cases passed, all 15 of them. So I'll do one thing. If you guys have any questions, just put it in the comments. I will commit this repository. The main branch will be having just the questions. You can pull the questions and practice them. I will also create one more branch called answers branch, and in that I will push the solutions if at all you guys want it. But I would suggest you guys write the code on your own, because only then you'll remember the answers. So with that, I guess this stream will be over. There is nothing else to be done here. So the next stream will be about the um, difficult questions. So they'll be like little more complicated questions in multi-threading itself. So see you guys there. I don't know if there is any other housekeeping left. I don't think so. So if you guys have any other questions, just let me know in the comments. Okay, so thank you all. Thank you for joining. See you in the next stream. Bye.